What's up guys, this is Masi. Welcome to my channel. This video I want to show you how to find the pH of a mixture of weak acids. So when we are dealing with a mixture of weak acids, we have different concentrations of proton coming from different acids. So we want to find out what's gonna be the total pH or the final pH of this solution. First example I have is the pH of a weak acid mixtures. Calculate the pH of a solution that contains 1 molar of HCN with Ka 6.2 times 10 to the power of negative 10 and 5 mole per liter HNO2 with Ka 4 times 10 to the power of negative 4. Also calculate the concentration of cyanide ion Cn- in this solution at equilibrium. So basically we have two acids and both of them are weak acids. The Ka value for both of them are given. We can write the equation for both of them. HCN gives us proton plus Cn- and HNO2 gives us proton plus NO2-. And also water is going to be proton plus hydroxide ion. So a mixture of three acids, because as you remember, water is an amphoteric substance, so it can act as an acid and base. So basically we have three acids in this case. So a mixture of three acids might lead to a very complicated problem. However, the situation is greatly simplified by the fact that even though HNO2 is a weak acid, it is much stronger than the other two acids present in this solution. So if you compare the Ka values, for HNO2, Ka is 4 times 10 to the power of negative 4, which is much greater than the other two K values for the other acids, which is HCN and H2O. Thus, HNO2 can be assumed to be the dominant producer of proton. And we will focus on the equilibrium expression. So Ka will be 4 times 10 to the power of negative 4 equals to proton concentration times nitrite concentration divided by HNO2 concentration. So initial concentration here we have on the left hand side 5 and the other two 0. After dissociation, equilibrium concentration we have 5 minus X for HNO2. For nitrite we have X, and for proton we have X as well. So if we have the I stable, initial change in equilibrium, we have 5 minus X will be 5 minus X. For proton, it's going to be H plus. It's going to be 0 plus X is going to be X. And for nitrite, it's going to be 0 plus X will be just X. So Ka, which is 4 times 10 to the power of negative 4, will be X times X divided by 5 minus X. And it's approximately equals to 5 because X is much smaller than 5. So X squared will be 5 times 4 times 10 to the power of negative 4, which will be 4.5 times 10 to the power of negative 2. So that's the proton concentration. And if I want to find the pH, we put it in the formula, negative log 4.5 times 10 to the power of negative 2. So pH will be 1.35. So as we said, although we have three weak acids in this example, one of them has much greater Ka comparing to the other two acids. So that's why that acid is going to be dominant. So it's going to be the dominant producer of proton, and we consider that one as the main proton producer. And we find out the proton coming from that acid, and based on that we can find the pH value. I hope you enjoyed this video. If you found it interesting and useful, please like this video, and also you can subscribe to this channel to have access to many videos regarding chemistry and math. Thank you for watching and have a great day.